So, in this video we're going to have a look at a few problems using the summation of the first n terms of a geometric series. So the first problem says a geometric series has first term 2 and a common ratio -3. We want to find the seventh term. Well, for part A, because we're looking for the seventh term, we're going to use the nth term formula. So if we take our key bits of information, A, our first term is 2. R, our common ratio, is -3, and n is equal to 7 because we're looking for the seventh term. So U7, if we substitute in, is 2 times -3 to the power of n-1, so 7 minus 1, which is equal to 6. And if you put that into your calculator, you end up with 1,458. So part B then says we want to find the sum of the first 5 terms. So for this problem, we set it up in the same way. A is equal to 2, R is equal to -3, and because we're looking for the sum of the first 5 terms, N is equal to 5. So we have S5 is equal to, if we substitute in A, which is 2, times 1 minus R, which is -3, to the power of N, which is 5, all over 1 minus RR, which is -3. If we type that up a little bit, we have 1 minus -3, which is 4. So we have 2 over 4, which is a half on the outside of our bracket. We have 1 minus -3 to the 5 is going to be -243 times that minus, so we're going to get plus 243. 243 plus 1, 244 times a half is going to get us 122. So the sum of the first 5 terms is 122. Moving on to question 2 then, we want to find the 15th term and the sum of the first 6 terms for the following 2 geometric sequences. So in part A, we've got 2, 4, 8, 16. Well, let's list our key information. Our A value, our first term, is 2. The common ratio R, well, we can find that by doing the second term divided by the first term, so 4 divided by 2, which is equal to 2. And for the first part of the problem, we're going to use n is equal to 15 to find the 15th term. So we have U15 is equal to 2 times 2 to the power of 15, take away 1, which is 14. And that gives us 2 to the power of 15, which is 32,768. Obviously your calculator will be useful here. We then want to find the sum of the first 6 terms. So we're still on part A. We've still got A is equal to 2, R is equal to 2. This time our N is going to be 6, and we need to substitute it into the summation formula. So the sum of the first 6 terms is equal to our A value, which is 2, times 1 minus 2 to the power of n, or 2 to the power of 6 in this case, all over 1 minus 2. 1 minus 2 is -1. 2 divided by -1 is -2. So we can write it like that, or we can write it as 2 times 2 to the 6 minus 1. And if you put that into your calculator, you end up with 126. So that's our first one then. We then have part B, and we have our second sequence, 3 minus 6, 12 minus 24. So let's take our key information. A is equal to 3, R is equal to -6 over 3, which is equal to -2. And for the first part, n is equal to 15. If we substitute that into the formula to find the 15th term, u of 15 is equal to 3 times minus 2 to the power of n minus 1, which is to the power of 14. Again, you put that into your calculator and you end up with 49,152. The second part, same scenario, we've got a is equal to 3, r is still equal to minus 2. This time our n is equal to 6. The sum of the first 6 terms, if we substitute in, we have 3 times 1 minus 2 to the n, so minus 2 to the 6, all over 1 minus 2. 1 minus 2 becomes 3. 3 over 3 is just 1. So we have 1 minus 2 to the 6, which again, if you put that into your calculator, you're going to end up with minus 63. And that's how we can solve some basic problems using the nth term formula and the sum of the first n term formula for the geometric series.